Good afternoon and welcome to this session on insights through the use of smart data. My name is James Milne and I'm joined here by my colleague Nathan Pearce from Myriad Technologies. Now during this session we would like to discuss some of the strategies and technologies that can be used to start to extract insights out of data in a more effective, smarter way. So before we get started, let's have a look at some of the challenges that we're seeing in the marketplace. Over the last few years, we've gone through this explosion of data. So over time, we've collected historic data. Now this could be records, it could be documentation, it could be lessons learned that are gathered from multiple places within the organization. But this is now being combined with the IoT explosion. And so we're starting to see lots of sensor data being generated and collected. This data needs to be collected, stored, and ideally categorized and processed in a way that enables us to gain insights from it. So some of these challenges are starting to really present stumbling blocks for a lot of organizations, especially when it comes to making critical decisions in a timely manner. We just don't have the bandwidth or the time to go through and process all of this data in one cycle. Combining this with connectivity issues such as DDIL networks where the connectivity is just not available, it's not possible to ship the sheer volume of data throughout the network. So let's look at a typical scenario that we might be faced with. We might have a node in head office, and this could be hosted in the CDC or in a protected network. We might have a deployed node, which could be a headquarters out in the field. We could also have another deployed node out on a vessel or a vehicle for that matter. Now, in the recent years, we've started to see Azure Stack becoming available to underpin these platforms. As we push these nodes out into the field, various users can use those nodes to create and access content on those nodes. As part of the planning operations, there could be massive amounts of source data which are created in head office and need to be replicated through the network. These have been the traditional patterns and practices that we've seen, and for the last 5 years this has become pretty commonplace. So it's very easy to exchange this information through the network in a timely manner that allows each group of users to access the same information across each node. Now, one of the challenges we're starting to see in this space is high-def video being produced by ISR sensors. Now, some organizations are starting to struggle with the sheer volume of video content that's being generated by these assets, and they're choosing to go for strategies where they're lowering the resolution of the content, but still the sheer volume of the amount of video that's recorded still prevents that content being replicated through the whole network. And of course, with other vehicles such as aircraft having telemetry data and other mission data being collected and pushed out through the network in a congested network, this is a very challenging scenario. So one of the challenges we're looking at is how do we look at standardizing the metadata around all of that data in a way that we can process it on the local node and then have the metadata and key frames pushed out through the network to ensure everybody gets the access that they need or the information they need at the right time. This can be underpinned by a common sensor platform that allows normalization of this data, and as it's pushed out through the network, we can use targeted automation to trigger the appropriate business processes or ensure that the information bubbles up on the appropriate dashboards at the right time.
Thanks, James. To efficiently generate insights through the use of smart data, we need a way of capturing, processing, and standardizing all of the different data feeds that we can capture out at the edge so that we can make it available for distribution and targeted automation at each point within the environment. Now, this next section is all about the types of data that can be captured and processed in these edge environments, the concepts behind the distribution of that data, and some specific use cases that we've looked at around some of the advantages that we can provide by employing some of these technologies out in the edge. Now, within Defence Force, there are numerous data streams which, if processed and distributed efficiently, will not only provide insights that can increase the effectiveness of any deployed force, but will provide an overall advantage to any commander or decision maker. These common data sets can include things like images, full motion video, telemetry from people or even vehicles that are being rolled out, and some emerging data sets from things like IoT devices and any additional sensor that's integrated into vehicles like UAVs. But we cannot dismiss the importance or the ongoing need for things like scanned documents or even personnel data out in the field as well. Now, classically transporting all of this data around different environments or places within the network involve things like shipping hard drives around, USB keys, sending emails or CDs of data, in some cases a concept we've heard quite a lot of called swivel chairs, due to the lack of either technology at the edge or available bandwidth to make this data available electronically for analysis. With technology like the Azure Stack devices, the capture and processing of this data can now be done in the field using the latest in-cloud tools and even in disconnected scenarios. By using replication tools, we are able to efficiently move this data around, making it available in other geographically dispersed locations, e.g. from a forward operating base back to our main headquarters. Now, the concept that we're using, or the approach that we're using to do this, is we are using some tooling that drastically compresses the data, in some cases by 1,000 to 1, is network aware and intelligent enough to understand when it is either connected or operating offline. When a connection is lost, the environment continues to operate and all of the services on there carry on, so data capture and analysis still happens. When that environment comes back online, the technology is smart enough to handle its conflicts and effectively sync that data back and forth using a minimal amount of bandwidth. Now, in a lot of cases, bandwidth is at such a premium that replicating something like full motion video or any other big data set we have captured is not feasible. In these scenarios, we employ the use of tools that I mentioned before that will not only capture and process that video data stream, but perform full analysis and entity extraction as metadata as well. Now, by replicating just this metadata, we drastically reduce the network load while still providing a smart data feed back to other environments for analysis, automation, and smarter decision making. Now, one specific use case we can look at is the multitude of sensors on the new 5th generation Joint Strike Fighter. By efficiently capturing the sensor streams through a common sensor platform, standardizing it, processing it, and extracting entities and metadata, we can make it available for distribution through something like a coalition network rather rapidly. Any security or classifications attached to that data flow it throughout the network, ensuring the right people see the right information at the right time. At each point throughout the coalition network, process automation can be applied to the data, so we can start to introduce things like users receiving notifications or tasks to go and interrogate some of that processed and analyzed data even further. Now, in this scenario, you'll see we are looking at a coalition scenario, so at each point we can still provide a complete operating picture and make that available to users on the specific environments they're working within. Now, another use case that I'll show you in a moment is using geospatial data and map overlays aggregated together to support something like pandemic support activities. By bringing all of this data together, we can help provide additional insights and ultimately provide an advantage in the field. Now, stepping into our demo environment, the first thing that I want to show you is some of the video capture and entity extraction capabilities that we can start to provide out on some of these edge devices like the Azure Stack family. Now, if I come down into my sensor repository, notice this is where I have some videos that have been made available for me to ingest. Now, if I look at cheyenne.ts, you'll notice it's a 58 meg file. It is full motion video to MISB standards. That's been made available and unclassified for us to use in this demo. Now, the ingestion process for this demo, whilst I'm doing it manually, can be automated. But if I go ahead and if I drop this file into my mission assets, you'll notice it comes up with an import prompt for me. Now, if I go ahead and import this file, you'll notice it only takes a few seconds to ingest and analyze and extract information from this file. Now, with this tool MediaFlux, it is capable of ingesting and analyzing gigabytes of data an hour, and does so quite efficiently. So things like full motion streams from UAVs or any other video capable asset that you might have is completely feasible. If I go ahead and dismiss this and then click on my asset within the missions assets folder, you'll notice it has automatically extracted and attached a whole set of metadata against this file. Now, this is completely configurable to your specific needs or the type of data that you're ingesting into the platform. Now, first thing you'll see, we're picking up some of the time series, coming down into the metadata. You'll notice things like the name, but then a whole heap of UAS MISB associated metadata as well. So the timestamps or the start and finish dates of this particular file. The security classification has been automatically extracted. Things like the designation, call sign, and tail number of the vehicle that it was captured from. And then some additional information like latitude, longitude, and altitude. If I go ahead and right click on this file, you'll notice I'm also able to generate things like CZML and KZMLs. So just by analyzing, extracting metadata from this particular video, we're able to go so far as reconstructing the actual flight path and then overlaying that onto something like a map. Now, going back to our concept earlier of replicating just the metadata associated to full motion video, rather than trying to replicate, even in this instance, a 58 megabyte file over some of the very constrained networks that are in use within defense, especially out at the edge, instead, what we would be replicating is just the associated metadata. Along with that, we can also extract keyframes and make that information available, or that data available, anywhere within the network for analysts to interrogate further or to inform automation. So someone doesn't need the actual video file to start to generate insights and make smarter decisions about what's happened on that particular flight or what has been captured. Now, to quickly talk about a different type of data that we can actually store within here. Notice I've got a people data set in my collections. Jumping into here, you'll notice I've got two objects within here. One is just a person that we've gone ahead and created, and then a image, and particularly an image of a degree. Now, the other thing that this tool lets us do is create our own taxonomies and our own relationships between objects as well. So you'll notice, just as before, we've got some metadata associated with this, but a little bit differently to before. You'll see I've got sticks and person. So this is a taxonomy that we've gone ahead and created within this demo environment. Again, completely configurable based on your needs or any particular mission that you might be running as well. Looking at my other object, because it is an image, you'll notice it has applied some specific metadata, but we've also applied it to that taxonomy or the custom taxonomy that we've created as well. Now looking down in the bottom right here, you'll notice the relationship. So we've been able to create a relationship between these two objects within this particular platform. And if I navigate back over to my person object, you'll see that relationship is there. Again, these relationships are completely configurable by end users or administrators to support your particular needs. Again, these relationships are stored effectively as metadata that can be replicated back throughout the network as well. Now, the other demo that I would like to show you is based on the pandemic scenario that I touched on earlier. So this particular platform is used to manage some of the largest geospatial stores in the world, and it does so quite efficiently. In this particular scenario, it was for a demo that we put together, and our team went off and found a bunch of information available on the internet around where are specific types of locations and the actual tracking of the pandemic throughout Finland. So you'll see over on the right hand side here, I have my different layers or filters that I can apply based on data that's stored within here. So as I go ahead and start to add additional data sets to it, it pops up on the screen here. Now the scenario that this demo was put together for was, as we track the cases and the flow of the virus across Finland, in support of that, where would defense actually be looking to set up locations, and what locations were available to them or existing infrastructure to use in support of that. So things like educational facilities, police cases, we can then start to, using some of the time series overlays, start to track the actual pandemic as it happened across Finland. Now, by making all of this data available all throughout the node network, not just in one particular location and then waiting for a repatriation activity back into the core and then distribution back out to other edge locations, we can very drastically increase the efficiency and start to provide all of the data that people might need to make better decisions. Now, to take that a step further, I'd like to hand back to James to talk about how we can start to apply some artificial intelligence and machine learning capabilities to this data, not just at the network core, but all the way out to the tactical edge as well.
Now let's have a look at how we can use AI to manage data. So managing massive data with artificial intelligence. One of the trends that we touched on earlier is the fact that Azure storage is cheap. And what this is starting to lead to in the marketplace is people are using cheap storage just to zip up their data and store it online. The challenge here is, what's the point of it? We end up with storing piles of files. Who's actually going to go through and sort all of these files for us? Who's going to structure it? How is it going to be organized? And do we need to start using one taxonomy or many taxonomies to start tagging this content? And even if we do start the taxonomy conversation, are we using organizations, nations, units? Do we look at tagging it by mission, task force, or location? Or do we take a completely different approach, which is a functional approach, to try and tag things based on what they are or what they're used for? A lot of these challenges usually fall to an information manager or a knowledge manager within the organization. What would be ideal is if we could use something like artificial intelligence to go through and sift through all that data and actually categorize and organize it for us. This is where products like Azure Cognitive Services come in to help us categorize and organize our content for us. Now, a really good example is, most of us should be familiar with the JFK assassination many years ago, and the resulting investigation that came out of the assassination saw many documents created. Now, it's only been recently that the US government has actually released those files, Now, starting off, they released the first batch of 34,000 files, and to give you an idea, that's a stack of paper that's 11 feet tall. They then actually released another 4 batches of those documents, resulting in over 36,000 documents. Now, these documents were made up of photographs, scanned documents, handwritten documents, and another challenge was they were written in multiple languages. So for somebody who was looking at this data, it presents a significant data load of information that needs to be processed. Now, Microsoft actually threw artificial intelligence at this problem and have actually released a sample on GitHub, which allows us to consume as Azure Cognitive Services to process this data. And so there is actually a really good demo out on the web for JFK Files. So if you'd like to go and have a play with that, just try Googling JFK Files and have a look. And it is fascinating to be able to read through that amount of data and see the relationships. Now for us, we saw the opportunity with a customer recently where they'd collected 2 decades worth of lessons learnt data. So we tapped into the GitHub project and leveraged the JFK files to create an example that we could demonstrate to a customer that we can process large amounts of data, and that data could be scanned documents, could be photos, it could be multilingual, and we could actually extract the entities and the reoccurring themes out of that data set to allow them to start to drill into those documents to find out what those reoccurring themes were before they embarked on their next mission. Now, bearing in mind this is just using off-the-shelf cognitive services, so it took us about 2 weeks to wire it up. Now I'm just going to switch across and we'll have a look at the system in action. I've now switched over and logged into our NASA demo environment, and you can see I'm presented with a very simple search web interface. And if I go ahead and search the data set, you can see, looking for a simple query of the Mars rover, I'm presented with multiple documents. And now all of these documents have been scanned in, so we're actually doing keyword recognition over images or scanned documents. And you can see if I click on any of the documents, we've extracted the text out, and as I move through the text, the appropriate document is moved so I can see where those keywords are actually referenced within the documentation. If I go back to my search results, we can also see that the cognitive services have also extracted keywords and entities out of the document. And this has all been automatically tagged by Azure Cognitive Services. You'll also notice down the left-hand side, the entity extraction has also worked out the various organizations, the topic areas, key phrases, and other NASA entities that I can now filter my search results on. Where it gets really exciting is when we can flip over into the entity view and we can start to see how the various entities relate to each other. And we can start to drill through each of the entities to actually find more information about each of them. The search also allows us to index handwriting. So if we look for a simple search like Columbia and have a look at the actual results that come back, you'll start to notice that the search engine is actually picking up on handwriting from a photograph of a piece of equipment. You can even see that the text that's been extracted out of the photograph even includes serial numbers and model numbers on the side of devices. So this shows you how effective the text extraction mechanism can actually recognize text from a photograph. So having a look at the architecture behind the demonstration, you can see that Azure Cognitive Search allowed us to store the files in Azure Blob Storage in a completely unstructured mechanism. Those documents were then consumed through the cognitive search indexing pipeline, which allowed us to consume documents and images. And then we used various services that allowed us to perform OCR, or optical character recognition, and also process handwriting. Computer vision also identified what certain objects were, and you would have seen the highlighting mechanism. We can actually use the redaction service to either highlight or redact keywords out of those documents. From these services, we extracted the full text and then used additional services to extract the entities and the cryptonyms out of the dataset to give us a well-structured interface that you just saw. Those structures are then surfaced up in a way that people can search them, and we can also see how those different entities relate to each other. Now, switching across to a new service which has just recently been released by Microsoft, Project Cortex has recently been announced as SharePoint SYNTEX. So as we've just seen, the power of Azure Cognitive Services are very powerful and can be orchestrated in a way to help us gain insights out of our own data. However, Project Cortex takes these services to the next level. Project Cortex is baked into Office 365 and allows us to create a knowledge network. Now, most people aren't familiar with what a knowledge network is. So let's explore what is a knowledge network. Most organizations accumulate a wealth of organizational knowledge over their lifespan. And this knowledge could be technical information, it could be reports, manuals, reference manuals, white papers, all sorts of documentation that gets collected over time. We also typically create communities of practice or communities of interest around technical topics. We may also have organizational information, such as how we are structured, what our business activities are, what policies, procedures, and doctrines we follow within the organization. The organization may have various processes and who participates within those processes. And then on an individual level, each person within that organization has a status, position, rank, role, membership in different groups and different organizations outside our organization. They may also be considered a subject matter expert who has specific know-how on how to participate in various business activities or business processes within the organization. Now, a lot of organizations also have some sort of ad hoc activities, such as missions or exercises, that occur on an infrequent basis. But these are still very valuable because they're business activities that generate information, they have objectives, they have outcomes, and we might want to start to draw on some of the lessons and insights out of these business activities so we can feed them back into future exercises. So this wealth of knowledge presents a lot of organizations with various challenges around how do we categorize and organize this information. So Microsoft has coined the phrase the knowledge network. So all of this information, the information in people's heads, the information in different systems, is considered to be the network of knowledge within your organization. So how do we harness this? So Microsoft has started to bake Project Cortex into Microsoft 365. So in the foundation, in the platform where we start to create and share knowledge within your organization, so this could be something along the lines of GovTeams, which is hosted in Office 365. As we are creating videos in Microsoft Stream, or creating communities of practice or communities of interest in Yammer and Teams and other SharePoint sites and spaces, that information can be aggregated together and we can start to generate insights from that. Now, the classic example would be all the information that's stored in Microsoft 365 is searchable, but Project Cortex offers to take this to the next level. Project Cortex is going to help us manage our content in the background. So it's going to use AI to automatically tag and potentially secure that content. And we can then use that to organize the information across the whole organization. And this will then empower users to find information as that information bubbles up through their everyday applications. So in this example, you can see a topic card appearing inside Microsoft Outlook, which allows somebody to hover over a keyword in an email that then explains what that keyword actually means by referencing other content throughout the organization. So, being a platform service, Project Cortex is baked into Office 365. And the products sitting on top of Project Cortex, being SharePoint, Teams, Yammer, Outlook, and Microsoft Search, allow users to find that information. Project Cortex itself manifests itself within the system as a number of key attributes, such as topic cards. And as I mentioned earlier, if I was to send you an email and use a specific keyword in that email, when you're viewing the email, you could hover over the keyword and you'll see a topic, which then aggregates all the corporate knowledge about that particular keyword in a very simple pop-up card that allows somebody to quickly and easily consume and understand what that keyword is. Project Cortex will also surface information up as topic pages. So, talking about how you categorize and organize information based on taxonomies or categories or tags, traditionally we've physically stored information in particular sites. So let's say we have a different site for each exercise that we perform in the field. One of the challenges we're going to have is rolling up common topics across each of those exercises in a way that people can start to see those reoccurring themes. This is where topic pages can be generated by Project Cortex to aggregate common information across the organization. Project Cortex also has a knowledge center, so the users can actually come in and start to explore the different topics across the organization. So Project Cortex can actually start to curate some of this content for us to make it easier for us to discover what corporate knowledge we actually have in the organization. Project Cortex also has a content center. Now, the content center allows individuals or subject matter experts to come in to the content center and identify what information has been discovered by Cortex, and we can then start to map or train the artificial intelligence through the AI builder to help teach the machine how to classify that content moving forward. So rather than having to start from scratch, this allows us to feed back into Project Cortex what content is and how significant it is to us. It also allows us to start creating relationships between different content, so Project Cortex can start to make relationships between different entities. Now, as we mentioned, Project Cortex will consume information out of Microsoft 365 and fold that into the knowledge network and make it searchable. But this is where we open up other opportunities of being able to connect to other repositories to have that information bubble up through the knowledge network. So through Project Cortex, we can use these new AI services and capabilities to feed the machine learning. So even if we were to go in and manually tag content, that will help the machine learning understand what certain data is, and it will learn from our manual tagging. It will also provide us with automated object detection and tagging out of the box. So as we saw in the previous demo, where Azure Cognitive Services could actually recognize handwriting on a bulkhead, Project Cortex will also be able to automatically detect objects from photos and scanned documents that have been uploaded into Microsoft 365. We also have the capability for automated processing of forms. So if your organization is using classic PDFs as an electronic forms medium, as those forms are uploaded into a particular library, we can have automated forms processing which can detect the fields and the values of those fields and have that automatically processed as part of the upload. This obviously extends into the ability to classify your files and start to extract entities out of those files. So this could be for contract management, manuals, or any other sort of documentation. Once Project Cortex starts to understand what certain entities are, it can start to automatically extract those out of documents. And this is where the AI builder comes in, because we can also start to train the classification engine on what certain entities or what certain document types are. Project Cortex will also provide us with a monitoring dashboard. This is part of the Content Center that allows us to monitor how metadata is being used within the Office 365 tenant. And it can provide us with analytics across all the organizational content to help us identify whether we're using those terms correctly and whether we're missing certain terms. So this helps us identify things like synonyms and antonyms for different terms, and we can start to re-tag content or use AI to go off and do that tagging for us.